Hi everyone, I'm Matt Phillips. I'm the Chief Operations Officer here at ScottLogic.
Hi, I'm Oliver Cronk, the Technology Director at ScottLogic.
Ollie, so great to be talking to you today. We recently took part in a spirited panel discussion, I think, with Chief Disruptor Live, and we wanted to track through some of those topics here today. So I think we were talking about transformative technologies and talking a little bit about some of the risks and unintended consequences and how organisations can navigate wisely through that. One thing we didn't really do, though, which I think kind of makes sense to start this, is like transformative technologies. What, in your view, do we mean by transformative?
Yeah, it's kind of, I guess it could be a bit of a grey area one, but for me, it's where there's been sort of a significant disruption or change to the operating model, the business model of the company. It's not just another programming language, right? It's something like cloud, which made people rethink how they go to market with software and products, and democratize access to technology to startups and so on and so forth, right? So I think it's these big, perhaps once or twice a decade type big technologies that come along and make people go, all right, the world is shifting now, or it has shifted already, and I need to get on the train. I need to make sure I'm keeping my organisation relevant and ready for what's going to come.
Right. And cloud, mobile, the internet, PC, go back far enough, printing press, electricity, somewhere in between those points.
Exactly.
It's that kind of thing, yeah?
Yeah.
And that doesn't happen all the time, and consequently, we're used to this idea that, there's the next big thing happening every year. But the reality is that's not true, is it? Some technologies are not arriving at that level of disruption.
I mean, it's funny, isn't it? As technologists, I think we like to think we embrace change and embrace new technology, but we actually do get stuck in a groove with particular patterns of, I guess we get comfortable, don't we, with a certain way of deploying software or setting up technology, and then something comes along that makes us go, oh, okay, no, I'm going to have to rethink that. And of course, recently we've had generative AI, which everyone is talking about, but it is a classic example of something that's made people stop and pause and go, wow, okay, this is really going to change how I work with customers or how I generate documents, or it's really sort of making people rethink how they'll be relevant, how their organizations will be relevant to their customers, what supply chain looks like. And it's one of those examples of a big ticket item that technologists are paying attention to, because there's a lot of uncertainty around it. But the big thing for me that I really liked about what we covered on the panel was the non-happy path, right? There is lots of excitement about and buzz about the potential for these technologies, but there's not enough focus on, hang on a minute, what happens if this goes off the rails a little bit? What happens if the intellectual property that I'm feeding this thing with gets reused in a way that I'm not comfortable with? And I don't think those things are running through people's heads at the moment, because they're very much in the excited space of, wow, where could this lead us, rather than hang on a minute, where could this lead us?
You and I are going to want to sort of try and discuss here, I think we've spoken before on these topics, a kind of promote a sort of a clear-eyed view on this stuff, right? Which is to say, we're not in the kind of camp which is hyperbolic, or at least we're trying not to be,
right,
although we're excited.
Yeah.
But at the same time, we're not in that kind of, what pejoratively I think is being called doomers camp, right? It is two things at the same time, right? The technologies are both very powerful, and at the same time, there's a lot of risks and challenges, and you need to be clear-eyed about those.
It's something that's sensible, pragmatic head-on, I think. Like, it's easy to get carried away by the hype. It's also perhaps easy to kind of, to a lesser extent, get swept away with some of the conspiracy theories of this is going to take over the world, and the reality is somewhere between the two. So taking that sort of pragmatic sort of path, like looking to take advantage of this technology, but not being blindsided to the downsides.
Right. Okay, so before we get into the risks, though, again, we didn't get a chance to talk about this. Why now has it exploded into public consciousness, right? I mean, neural networks, deep learning.
Yeah.
We've been at this for a long time.
Yeah.
But why now is it that many people around the globe, right, I guess we can say a few billion at this stage, of kind of, this feels like a big deal to people, and it's exploded into public consciousness?
I think the one word is language, right? I mean, so when I was studying computer science just over 20 years ago, I was working with some very primitive natural language processing and generation technologies, like really, really primitive compared to what we're looking at today. And I think it's the fact that computers they now feel like they can talk to us in our language. Now they're just doing, as you and I both know, they're just doing a very good job of statistically generating the next most probable word, but the end user doesn't necessarily know that. The end user thinks this is the computer talking to them as if they're another human being. And so I think that's what's captured everyone's imagination is, wow, okay, now computing has got to a level of sophistication that it can converse in our natural language. And I guess why now is that possible? It's simply that evolution of different foundational technologies. You started reeling off some of those sort of transformative technologies earlier. And ironically, one of the big things that's enabled this to happen is the internet itself. What some people don't quite realize is the internet itself was a requirement for these technologies to work. All of the text that we've ever shared in chats, in message forums, in blogs, in articles, BBC News, other news publications, all of that has been used as an input. And so it's not just raw compute power. Yes, that's clearly been a big thing that's been advancing, but it's the data. I mean, as everyone says with AI, but it's true, the data is critical. And it's only recently that we've had the ability to kind of tap into that, that massive goldmine that is the internet, and then build a new technology on top of the internet using cloud technologies as well. So it's this kind of evolution really and we couldn't have got here without some of those building block steps beforehand, but now we are here, we're like, wow, okay, what's next?
It's very easy to look at the kind of the engineering breakthroughs. It's very easy to see some of the, the obvious progress that was being made with respect to folk that are either in the field or adjacent to the field, they work in technology. But I think, for a citizen, the fact that it is so obviously demonstrating remarkably good, and again, we'll come on to some of the problems, right? But some remarkably good language capabilities, right? So I think Yuval Noah Harari said, who's sort of famous Israeli intellectual, written a number of best-selling books that some of the audience will know. Language is the key to the human operating system. And
I love that. I love that
remarkably
quote.
good phrase.
No.
Which I think he was the first person to come up with it. And when I heard that, it was, that exactly encapsulates why this is a big deal.
And that's what I was kind of sort of alluding to, really. I didn't want to steal his exact phrase, but it is all about language as being that key to unlock how we kind of communicate. But then, of course, that's a double-edged sword, isn't it? Because you think about that internet content. Unfortunately, not all that internet content is particularly pleasant, kind, nice, unbiased, and therefore, you could describe this a bit like a swan, right? And what we see with something like ChatGPT is the part of the swan above the water. What we don't see is the furious paddling that it's having to do to kind of stop all of that hate speech and various other undesirable content essentially coming out to the end user. And of course, there are ways of fooling these technologies and getting them to kind of forget about their guardrails for a moment and reveal things that they shouldn't reveal. But that's the big thing we need to remember, is that a lot of this stuff has been trained on everything that's ever been said on the internet. And unfortunately, not all of that is kind, nice, or the sorts of things you would want being said to a customer or a colleague.
Bad actors using AI to do bad things. There's a whole, suite of risks that fall into that kind of broad category, right? Obviously, we had the AI Safety Summit recently at Bletchley Park. For my taste, it was a little bit too focused on the kind of more the existential risk and not enough on how we get to sort of binding regulations.
The bit around the existential risks I do buy into, though, is the misinformation and disinformation piece, right? I mean, particularly as we look at the UK and the US about, in the next few months, couple of years, going to go into election cycles. And the bit that I think is of a concern is misinformation, like people just accepting some of this content as true, and people being able to generate. We've already seen the classic examples of American politicians being deep-faked using this technology very convincingly, right? People looking like they're being arrested in New York, for example. Where I don't agree is it's Terminator. It's not. But what it is, unfortunately, is something that could mislead a lot of people that aren't as tech savvy as perhaps you or I and a lot of technologists that are. They don't understand what its limitations are. They just get wowed by it and impressed by it, and potentially very heavily misled by it. That's the bit I think out of the AI Safety Summit that the protection of democracy and how do we not have people sort of misinformed. That's the bit that sort of scares me the most in that existential sort of risk sort of discussion. But other than that, I agree. I think it needs to be more practically what's the boundary between government regulation and innovation, and how do we sort of protect privacy and intellectual property and various other things like that. those are the questions that I'm still not 100% convinced we've got good answers on yet.
I really agree with you about the the disinformation, misinformation risk. I guess I put that in the kind of catastrophic risk category more than the existential. But the point is that's already happening, right? And we need government to sort of get on top of that brief. And it's good that they're talking about it. It's good that they're meeting. There may be some technology answers to technology-created problems here, right? Watermarking of content, for example. But it doesn't seem to have easy answers that are being deployed as rapidly as the capabilities.
And it's funny you mentioned watermarking, because this was one of the things that came up on the Chief Disruptor discussion, was the fact that one of the kind of, I think it's Getty Images, who sued, I think, Stable Diffusion and some others, because it was very clear that the images that were being generated by their technology had Getty Images watermarks in them. So it was very clear that the models have been trained using copyrighted imagery. And so the bigger risk for most organizations using this technology is the intellectual property side of things, or the privacy sort of side of things. Like, what's this thing going to spit out that is perhaps no fault of your own, because you're not fully in control of all the training data this thing has been built on.
Right.
But what are the guardrails you're going to put around it to make sure it doesn't step out of line? And the interesting thing for me is we have to start talking about some of these guardrails a bit like policies we give to employees rather than system rules. Because as you and I have discussed, these technologies aren't like traditional databases where you make a query and it will give you the same result each time. There is a degree of non-determinism, right, where you ask for the something and it gives you a different result each time. And we like that because it gives us creative responses. But we also don't like that because it can potentially come up with something completely random, out of alignment with our brand, with our product, with whatever the context of the conversation might be.
So this feels, and I guess now getting into some of the specific enterprise challenges, right? We've been talking about some of the societal implications so far, and I think it's really important that we keep those in sight. Responsible deployment of this technology. Ultimately, if there are citizens and consumers at the end of this stuff, that matters for organisations, right? That they're thinking this through. But when we're thinking about how to kind of make this technology work, it feels like something you're touching on there, right? The reliability. What do we mean by reliability in this context?
Well, that's a big one, isn't it? Because for some people it would be just, is the thing available? Is it generating responses, right? And that for me is not enough for this one, because reliable for me, it's got to be aligned with, I suppose, the policy of the organisation that's building the solution, using it, right? So, and I'll give a tangible example, because we've done some work with a retail bank. So if a retail bank, for example, wants to use this technology and they want to talk to a customer about maybe opening a new product or something like that, like, reliable is it not recommending a competitor's product, right? Because actually without the guardrails, it can happen because it's trained on the whole of the internet. So it's not just trained on your bank's products, it's trained on the whole of the internet's bank's products. And therefore it will talk very generically about banking services unless you give it very specific direction to do otherwise. And so, that reliability point is, I come back to the sort of almost human definition of reliability. Like, when we start benchmarking some of these technologies now, we're looking for them to get to, say, 90-95% accuracy, because that's roughly where a human being gets to on some of the tasks that we're giving it. So we are now expecting slightly different, things out of our technology platforms. Before it was like absolutely nines availability. I want this thing to be up 24/7. Now, yes, maybe the system's available, but how reliable is the information it's producing? And trying to hit 100% or 9 nines is going to be nigh on impossible, at least for the short to medium term. So it's getting sort of human-like levels. So if one of your employees operated at this level, is the fact that the technology is now there or bettering it, is that a good enough level of reliability?
Yeah, exactly. So there's something here about being confidently wrong, which feels like the worst of all cases, right? You can be unconfidently wrong and expressing uncertainty, right? But the fact is that we see these tools because, again, of the training, the way they're trained, and the way these aren't. I think, as you point out, these are not. It's not deterministic in the classical computing sense, right?
But you have pointed out what I think is one of the worst issues with this technology is it is very overconfidently wrong at times. I know that we're seeing this being tweaked in some of the systems we're seeing now, but the fact it sort of authoritatively tells you something that's wrong. Like, we have our own internal chatbot called Scottbot that we've built, And I actually asked it yesterday, because I was doing my tax return last night. I actually asked it about P60s, and it gave me the first half of the response was correct, right? It was brilliant. It was bang on. It was like, go and talk to payroll, here's the email address. The email address was correct. It then recommended 3 links to our wiki. Unfortunately, all 3 of those links were wrong. I mean, they were rough. They were in the broad area of employment, but they weren't anything to do with a P60. I think one of them was like, benefits or something. In fact, one of them was completely wrong. So it's just, but it very confidently said, here's some information where you will find, further information about P60. And unfortunately, it's wrong, because it comes back to this. It's a statistical engine, and it can generate the next word, or it can kind of interpret language. And I do worry we are misusing it. In my mind, and I know people disagree with this. In my mind, it's a component of a system that is used for generating the language or processing the language. It is an NLG, a natural language generation, NLP, natural language processing tool. It's not the thing you just chuck the problem at and it will solve it for you. I think the people that are doing that either have got a very simple use case and they're able to get away with it because it's to a consumer, and the consumer accepts the fact that a fun selfie image of themselves is a bit wrong. It's like, okay, that's quite funny.
Right.
That's not the same when you're in a business to business or a regulated business to consumer environment like I talked about earlier. The kind of retail banking customer isn't going to laugh when it suggests opening a completely inappropriate account. Perhaps minimum balance required is £20,000 and this person only has £250 to save or something like that. Those sort of mistakes aren't going to be tolerable. So it's for me, and we've written about this in our papers, but the big thing for me is kind of just using this in the right way. Integrating it with other technologies that are more reliable, that can provide the guardrails, but using this technology where it wows, for generating content and processing content, but don't assume it can do the whole thing. It's not a silver bullet.
I can hear some people saying now, oh yeah, but humans aren't reliable either, right? And so as long as it's more reliable, then it's deployable, right? But one thing that really caught my eye earlier this year, and it was sort of overshadowed because of what was going on with ChatGPT, but yeah. I've been very into following the application of this technology onto board games. I was always into chess as a kid, and then very interested in how this technology got better and better in the gaming space, and obviously the big breakthroughs with Go. And I was amazed. I don't think anybody predicted that a human being would once again turn the tables on these incredible large models that have now overturned human beings, right? And back in February, a complete amateur developed a strategy, not even a professional Go player, developed a strategy that beat the best AlphaGo deep learning model. Now, there's something there about surprising failure modes to me, right? There's a lesson in there about this technology at the moment, which is to say how it fails is not as predictable in some sense as how a human being might fail, right?
I think you're bang on there. I come back to this sort of happy path versus non-happy path thing. I think it's easy to be wowed and delighted by this stuff and go, oh, this thing's amazing, it works, and then not test it robustly enough on some of those failure modes that you just sort of talked about. Because the fact it's creative in how it comes up with its content means, unfortunately, it's creative in how it could get things wrong. I mean, like another thing I'd cite is, and I did joke on social media that we'd shared something one of our colleagues had created where it asked for the recipe for crystal meth, and so I knew you'd have that reaction. So I did make that joke. But the point is, and by the way, we just to put your mind at rest, we didn't share the actual answer. We blurred it out. But the point was, it shouldn't be able to answer that. But because you can get very creative with language and you can persuade it, these things are almost vulnerable to social engineering attacks. Right. So if I kind of ring you up and try and persuade you to give me your username and password, we're in that sort of territory with these sort of technologies. Because unfortunately, they have impressive human qualities, but they also have human language type failings. And because human language is so diverse in like how you can express something or negate something, or you can essentially tangle these things up in knots by misdirecting them and misinforming them. And so that's how some of our team have been pushing the boundaries on this to say, look, hey, if you're building these applications, please be mindful that it's a bit like we're in the world at the moment where it's like before people really understood SQL injection attacks, and JavaScript, common JavaScript attacks, where, for those that haven't seen them, essentially there were very easy ways of exploiting databases with bad input to systems. So if a person put something in, you could potentially get the database to reveal information, or worst case, maybe even delete information. Where we are now is something very similar, where you can essentially craft a rogue message to get this thing to behave very differently. Because at the moment, the way we're taming these beasts is by giving them some instructions. But if you can tell the system to ignore those instructions, this thing then goes off the rails very, very rapidly.
Right.
And so I come back to this point about you can't use this thing on its own. You've got to use it in concert with other things, keeping it honest.
Right. That feels pretty intolerable for an enterprise, right? So how do you try and keep it, keep the beast caged then, to sort of roll with this metaphor?
Yeah. I mean, I think it comes back to data. If you're leaving this thing largely to the large language model or the generative AI platform, you are at the mercy of what it was trained on. And unfortunately, systems are very murky and opaque. You don't know what that thing was trained on. So you're going to need to feed it with your data. You're going to need to sort of make sure it's keeping it in context with your customer context or your process, your use case context. And the ways we've done that is with some existing technologies, but also some relatively new ones, like the likes of graph databases, which essentially map out the relationships between things. Because one of the things you and I have talked about is how these technologies are terribly bad at reversing the thing they've been asked. So, who is Tom Cruise's current wife or girlfriend, whatever, it might give you that. But if you ask it, who is the husband of that person,
right,
it can't do that reverse sort of
right,
direction. So the nice thing about knowledge graphs is they have that structure of what is related to what. It lets you traverse and link concepts. And so we've done that. Some of our proof of concepts have used that to make sure that the concepts in the conversation are linked to the dialogue that's then being generated.
So sorry, just to make sure that point lands for people, right? So this idea then that A is B means B is A, unfortunately, if all the training data examples are A is B, it can't work out that B is A.
Indeed.
Right, and so for that you need something else. Yeah. And this is where some of the work that you've been defining, I think, around architectures comes in, where
I mean, I think
the language model is a component, but it's not the whole story.
The data architecture is really, really important because there's a lot of talk of prompting, this prompt engineering piece, which is essentially how do you get these things to do what you want them to do. And what we're looking at is how do you use data in the right format, in the right way, with smart prompting to then give you the language output you want, or process the input that's come in. And so knowledge graphs have been really, really powerful for that, and there's some good stuff we published on our blog about that, and also other people are talking about it now as well. And there's also the likes of vector databases. So vectors, for those that don't know, essentially the whole of these large language models operate off of vectors. So vectors are essentially what is the statistical way that these things are built. So using a vector database is a bit like using the same sort of technology these things are trained on to then inject the right sort of data points into the conversation at the right points. And then I think don't disregard those legacy systems that have customer information in them, right? Yes, they're going to need to be either sped up or cached so that they can link to the queries that you're making of the AI model fast enough. You're not going to you don't really want the customer to sit there and wait while the database query finds out their account balance. That's going to need to be stored in memory somewhere. So if the large language model needs to know what accounts do I have, how much money is in them, what's my credit score, that needs to be available, like that to the large language model, much like it would be to a customer services representative who would have that information at their fingertips in a call center. You need the same sort of thinking for some of these technologies, because if you don't have those inputs, it's going to start hallucinating and coming up with its own answers, which won't be correct.
So you alluded to, there's some alternative views around just you can somehow, the large language model is the kind of the soup to nuts solution. I mean,
look at
are there people advocating for that?
Well, look at what OpenAI have just announced, GPTs, right?
Right.
They're essentially looking to kind of build an app store around OpenAI.
Right.
And of course they want to monetize. It's clearly been very expensive to build this technology. They're looking to monetize it in every which way they can. But I do question quite how effective just that GPT technology don't get me wrong, you are plugging in a document or some training data to it. But I think that's really going to be quite limited.
And you and I are coming at this from the point of view of enterprises doing hard things in
Yes.
regulated environments, right?
If it's a consumer app that's, I don't know, I'm struggling to think of an example in the text world, but in the, in the image processing world, of course, there was the likes of Lensa, which, you uploaded a selfie to, and it created some interesting sort of,
Right.
versions of yourself. There's a very low failure risk with that one. You just won't use the image, it doesn't look very good.
So people know I love wine, for example, right? So if I go and find a GPT that
gives you a wine recommendation.
Right, and it's a sentiment analyzer around that, fine. But for the sorts of clients that you and I work with,
for government clients, for financial services clients, utilities, anyone who is in a mission critical business that cares about their customer relationship and customer reputation, quite frankly, all you have to do is look at what happened with some of the early experiments in this space, like Microsoft's Tay tweets, and that's used time and time again to point at something that went off the rails. It was persuaded by the general internet population to start spouting out very extremist messaging, and it had to be shut down within, I think, hours of its launch. Right. So if you don't get these things right, they can completely drag your reputation through the mud. Now, clearly, Microsoft has lived to fight another day on AI. People haven't remembered about Tay, and they haven't decided that Microsoft can't be trusted with AI at all. But that isn't necessarily going to be true of a consumer brand that puts out a product that completely gets it wrong in its messaging on how it talks to customers. I think it's just too big a risk for me to kind of just go, we'll build a GPT, we'll upload our product, maybe our financial products to a GPT, and then go, right, we'll put that on our website now and let that advise our customers. No sane person
I think
would do
if we're
that.
in a customer journey or with government, we're in a citizen journey. Never mind, we're at or near the point of decision, right? In some sense, the model needs to be kept in a zoo, right?
And that's
and then the right guardrails around it. Yeah. Now, I can hear some people saying at this point, but this stuff is going to get more and more reliable, right? We've got, roughly speaking, this technology in terms of how it's scaling, and so far scale has been the key to progress, right? Then it's 10x every year, right? However, it feels to me like the kind of architecture you're proposing at the very least is a hedge against the fact that might not be happening next year or the year after that or even the year after that. In other words, this reliability theme could be with us in an enterprise environment for still a frustratingly long time to come. And if you go all in on it as a soup to nuts, you may well get very frustrated.
And I think at this point we should also bring in the other unintended consequence of this, which is cost, right? And I don't always mean here financial cost. I also mean the energy footprint these things require, the amount of hardware and therefore raw materials that these things require, right? So to think that these things, it's just about how reliable they are. No, these things they're a bit like buy now, pay later type schemes at the moment. Like we're getting to sort of play with some of these technologies for free because the technology companies want us to start, exploring and experimenting with them. But they've been very expensive to train and they continue to be very expensive to operate. Now, clearly the technology industry is on a race to make them more efficient, both in terms of the models themselves and also look for hardware that executes the models, more efficiently. But they are very power hungry and very hardware hungry right now. And so, we need to be mindful about, if we're going to use one of these systems, are we justified in its use? Or actually is there simpler technology that could do just almost as good a job? And here's where I come back to.
Or a smaller model,
a smaller model.
Well. Right.
But here's where I come back to actually creating the right architecture. Yes, it takes more effort and it's more of a conscientious decision. But then you can choose which parts of this are really reliant on the latest and greatest, new AI model, and actually which parts of this can just be powered by a graph database or powered by, a smart solution that isn't so expensive. Because going back to the unintended consequences, we've already seen cloud. Like a lot of people who adopted cloud think it would save them money, and the reality is it's very flexible. It lets you be very dynamic and very responsive to customer requirements, but it doesn't necessarily save you money. And so I think we need to go into all of these transformative sort of technologies. You need to go into it with is this going to save me money, or actually do I need to look at the kind of business model in a different way now? Because I may not be today giving up a portion of my revenue, but in the near future, I will be giving up a portion of my revenue to run this technology stack or pay for the license fees or pay for the hosting of some of these technologies, which right now we're not really seeing because the prices aren't really fully transparent. So Matt, the Chief Disruptor panel discussion was really interesting, covered a broad range of sort of technology considerations. But what do you think the role of leadership is in navigating sort of the journey, I suppose, that organisations are going to go on over the next few years?
given everything that we've talked about with some of the challenges, right, I think many boards are going to be spending a good amount of time trying to work out how to get this right. They recognise that they can't ignore this, right? That's the first thing. And at the same point, I think they're starting to realise the challenges. For me, you can try and think of this in two distinct ways, which I think both are helpful. I think the first thing is that you have to recognise that a lot of the value from this, and I mean, it might be like half the value, is going to come from what I would call sort of bottom-up, task level
experimentation.
Right. And I mean, for me, that means actually, in the finance team, in the HR team, working out how this is useful, right? It's not, some system that technology define as part of a change project, and they build a thing and then they put it into the organisation and go, right, now we're using that to run this bit of the business. It's actually grassroots, local things, within the actual tasks that are done day to day, week to week, right? Now, that requires, just as the technology proliferates, so an understanding of how to use it appropriately needs to proliferate, right? Mm-hmm. So that feels like that takes you to education. Yeah. We've already seen some infamous examples arrive into public consciousness around what can go wrong, sort of, I think what you've called lazy experts, right, Ollie, right? But actually, I think in some cases, it's just a misapprehension as to what this technology is doing. It's right, you ask it arithmetic question, it gets the answer right. Oh, it knows arithmetic. Not really. And so I think it's very important in that kind of grassroots stuff where, again, I think probably, again, roughly half the value is going to come from that organisations are really just going back to their learning and development strategies and how to build, sort of AI literacy into the organisation.
And this is the sort of stuff you've covered in your recent white paper for us, isn't it?
Yeah, I try to talk about this kind of bifurcated strategy because I think the other half of it is that actually the sort of centralised kind of, right, we now need to, build a change project with lots of rigorous analysis is actually even more critical for some of the use cases around this. So which is to say that some of the problems with this feel more difficult to navigate than many other technologies. And so that's actually demanding a very controlled, rigorous approach to understanding what the risks are along with the potential rewards. So it is quite bifurcated in that sense, because, again, for the reasons we've been talking about, if this is going anywhere near a customer journey, never mind a point of decision, you're going to have to do a comprehensive view of what can go wrong with this. The reliability features, the hallucination aspects of it, data quality as well is going to be a big consideration. There's just lots and lots to do to get those high risk, high reward use cases right. And so, that just needs a lot of analysis and a lot of rigor. You mentioned experimentation, so I actually think that sits across both the bottom up approach and the top down approach. Okay. And what I mean by that is that, fundamentally, this isn't like any technology that we've seen previously. You've talked about the fact that it's not a deterministic thing. How do you test in this world, right? It feels to me that experimentation, curiosity, play, which most corporations are not great at if they're honest with themselves. So how do you encourage that curiosity and that opportunity to actually play with this stuff and frankly find some dead ends and kind of go, well, that didn't work, and try something else,
When you mentioned testing, and I know one of the big learnings for us has been almost taking a more statistical approach to testing. So I touched on earlier, like, as long as it's hitting 95% accuracy, we're comfortable. We'll move on to another area where it's not performing as high. And I think there's a number of blogs that we've put out about Scottbot and how we've tested that, which I think people might find quite useful around that space.
Yeah, very, very much so. What we've found through our internal R&D efforts, and actually with a client that we're working with in the legal space, is that the kind of paradigm we've been used to of build unit tests, anything fails, you've broken the build, go and fix that, just doesn't work because you're not going to have 100% pass rate. And not only that, it changes run to run. I mean, the model is changing from underneath you. And then the vagaries of the data and how you're fine-tuning it and so on. So it's more like benchmarking.
Yes.
And it's like, where do you want to set the pass rate, and also what trends you can see over time, right? So, if it was getting 90% and, it was getting 93% and 90%, that suddenly it gets 50%. It was, what the heck's gotten on there? And you've now got something that you can reason over and try to understand. But if you're just kind of looking at it from the point of view of, right, well, everything's going to pass, you're never going to ship anything, I don't think.